Okay, good morning, all of you. You see, continuation for yesterday topic. You see carefully, yesterday we spoke it under a simple reaction, different types of examples we have discussed. What I am discussing now is only for competitive examination point of view. Yesterday I told already rate of SN1 reaction. Under SN1 only we are discussing some examples here. The rate of SN1 reaction is directly proportional to breaking of carbon and halogen bond, and is directly proportional to stability of carbocation. You know very well, the stability of any particle is directly proportional to number of resonance structures. That's why it is directly proportional to number of resonance structures. Of carbocation. Okay, based on this one we are seeing so many examples or comparisons where we have to discuss. So first I am explaining, you see carefully. First comparison. I am taking one is ethyl chloride and another one is vinyl chloride. Vinyl chloride with CH2 double bond CH and Cl. Okay, first of all we have to check it very carefully. Out of these two compounds, which is more reactive for assemble mechanism, we have to discuss. See, first of all here in ethyl chloride between carbon and halogen single bond will be there, no chance for getting double bond because no resonance possibility. But if you see here what happening, carbon has 3 lone pairs after bond formation. They won't sit calm. What they are doing? These lone paired electrons and these pi-bonded electrons are in the conjugation. How can you recognize conjugation? They are separated by single bond. Okay, that's why what happening? First of all, these pi electron is shifting like this because here lone pairs is there. Then we are getting which charge? I will write here. So then we are getting on terminal carbon, you are getting minus charge. Here we are getting positive charge. Positive charge means what? Vacancy. Vacancy means is ready to accept the electron from adjacent atom. That adjacent atom is ready to donate the electrons. Then automatically what happening here? Positive charge is coming. Here newly we are getting a bond, that is nothing but CH, and we are getting double bond Cl, and after that plus charge is coming. Okay, we check it here. In this only we have carbon and chlorine connection through only single bond, but here we are getting carbon and chlorine connection through double bond. So I told very clearly, after that we are getting positive charge also right down here. So what I am telling is rate of SN1 reaction is directly proportional to breaking of copper and halogen bond. Which bond can be easily break down? That will be highly reactive. Okay, now see here single bond is there, here double bond is there. Which bond can easily break down? Single bond. That's why what can we tell? So this ethyl chloride is more reactive. CH3, CH2, Cl is more reactive for SN1 mechanism than vinyl chloride. CH2 double bond CHCl. It's very important for competitive work. I will give you one more comparison. You have to see very carefully. For example, I am giving benzyl chloride. Benzyl chloride means what? On benzene CH2 is calling as benzyl group. On this what will be the halogen will be there. I am taking one more compound. It is nothing but directly chlorobenzene I am taking. Okay. Now which is highly reactive towards SN1 mechanism I am telling you. You have to observe very carefully. Is there any chance to participate in a resonance by lone pair of electrons on the chlorine atom? No. Why? They are separated by 2 bonds with pi bond. So conjugation means what? We have to take the atom single bond carbon with single bond like this should be there. Means the lone paired electrons are having a conjugation with pi bond. They are involving in the resonance. Now, if you can take C double bond, single bond, and C double bond, C conjugation is there, automatically electron undergoing migration. We have to discuss in aromatic character concept first year to land already. And you see, for example, C double bond C on some X particle getting positive charge. or in conjugation. How can you tell? This positive charge at pi bond is separated by single bond, and if you can see C double bond C and Y minus. They are also in the conjugation. Why? Because this negative charge and the pi electrons are separated by single bond. These all are calling as a conjugated systems. Now you check it here. If you take these lone pairs and pi electrons, or in conjugation, now why they are having a intermediate bonds is 2. That's why there is no chance for conjugation. That's why what happening in this compound between carbon and chlorine we have only single bond. But here observe very carefully, on this halogen atom chlorine has 3 lone pairs. Here conjugation is going on because these lone pairs and pi electrons are separated by single bond. Then what happening? First of all, this bond will be shifting like this. Then what we are getting, I am writing resonance structures here. So after that, what we are getting at this carbon, negative charge is coming, remaining bonds is as it is. After that, we are getting here positive charge. Positive charge means what? Vacancy. Vacancy fulfilled with accepting of electron from surrounding atoms or from adjacent atoms. That is with chlorine. That's why what we are getting here, double bond we are getting, and we are getting here nothing but Cl. On that Cl we are getting a positive charge. So now what happening? This pi negative charge will undergoing migration, and again we are getting same structure we are getting. Those all are calling as a resonance structures. Anyway, in these resonance structures, what we are getting between carbon and chlorine, partially double bond is going, is not fixed. Again, migration means undergoing the shifting. That's why it's not the fixed double bond, it's a partially double bond formation is happening. That's why we can write here in this we are getting carbon and chlorine are connected with the partial bond. Means one is thick bond, one is dotted, not fixed. That means undergoing migration. So automatically what we can tell, automatically which bond is easy breaking? This bond. So this is pi bond, requires more energy to break it. That's why less reactivity. That's why we can tell rate of which is more. Benzyl chloride is more reactive than which one? Chlorobenzene. Questions you will ask like this only. Why benzyl chloride is more reactive for SN1 mechanism than chlorobenzene? In chlorobenzene resonance is possible. That's why between benzene, carbon and chlorine we are getting partially double bond breaking will be difficult. That's why the whole process will be going slowly. That's why speed will be less. I will give you some other examples. You have to see very carefully. Third example I am giving here. If you take for example vinyl chloride, allylic chloride. Allylic means what? Already you have this name. Allylic. Allylic means what? Halogen attached to carbon is calling as alpha. Next is beta. Next is gamma. Beta, gamma unsaturated compound is calling as allylic. Now I am taking benzylic chloride. Benzylic chloride. Okay, out of these two, which is more reactive towards SN1 mechanism, I want to explain or I want to predict that one. First of all, you see, is there any chance here conjugation? No. Here lone pair will be there, but the pi bond and lone pair is separated with 2 sigma bond. That's why there is no chance for conjugation. There is no chance for resonance structures. Okay, is there any chance already you studied here? No resonance structure. That's why what happening here also we are getting CCl bond. Here also we are getting a CCl bond. So based on that one we can't tell the concept. We have to go to further concept. What is that one? Stability of carbocation. Carbocation is what? Yes, this compound will lose Cl minus. So the bond is shifting like this. Then we are getting minus. Here we are getting plus charge. After that, what is that one? CH2 double bond, CH single bond, CH2 plus is coming. A positively charged carrying carbon only we are calling as carbocation. Now, is there any chance for resonance? Yes. Why? This positive charge and these pi electrons are separated by single bond. Alternatively, that's why they are in a conjugation. Conjugation means what? Migration will be possible. Yes, anybody? How it is happening? Positive charge is there, no? The pi electron shifting towards positive or away from positive or towards positive. Positive is what? Attraction. Electron. That's why the shifting will be going like this. Then we are getting here CH2 plus single bond, CH here minus and here plus. We'll get a new bond, CH2. The resonance structures are denoted by 2 hat arrow marks. You know, on the same atom, you are getting both positive and negative charge cancelled together, becoming neutral. No, on the adjacent particle, we are getting opposite charges. What is the meaning of opposite charges? Here we can see. Here, electrons will be there, plus and minus. What happens in donation? Each will form a new bond that will be represented by a double bond with B. You have to remember, these all will be coming in resonance structures formation. So on the same atom, we are getting both positive and negative charge cancelled together. We are getting a neutral particle. No, on adjacent particle, we are getting both positive charge and negative charges. We are getting indirectly. One is electron deficient, one is electron rich. They are involving in the new bond formation. So we are getting double bond. So same thing happening here. Yes, here minus is coming here, plus is there. So we will get that double bond. So how many resonance structures is coming here? Resonance structure number will be 2. Okay, now comes here. After breaking of CCl bond, we are getting which one? On, yes, this chlorine will be coming outside. After that, we are getting benzyl carbocation. We are getting. Now, is it also participating in the resonance structures? Yes, 100%. Why? This positive charge and pi bond is separated by single bond. Yes, now write down resonance structures. The pi electron shifting towards carbon, away from the carbon, towards carbon. Why? Positive charge attraction of pi electron. Then we are getting here minus, here plus. Minus and plus, double bond will come. Very easy. You already learned in the first year this aromatic compound concept. We are getting here plus. After that, like this. Still, can you write the resonance structures? Yes, this bond is shifting like this. Minus here, minus plus, side by side. That's why we are getting one more bond. We are getting here like this. Here double bond CH2. Which charge coming here? Positive. Again, still this bond is shifting like this. We are getting plus here, minus and plus again. We are getting a new bond. See, just resonance structures will come to know right. Yes, you are getting double bond here and here double bond CH2, and where we are getting positive charge here. Again, what happening? This bond is shifting like this. This bond is shifting like this means you are getting minus here, minus and plus again. New bond formation. Again, you are getting here plus charge. So under this we are getting how many resonance structures? 4 resonance structures we are getting. Resonance structures will be 4. Which is more stable? I told this one only. The stability of carbocation is depending upon number of resonance structures. So out of these two compounds, which is ready to lose the chlorine atom? This one. Why? Why? After losing, getting carbocation will be more stable, more resonance structure, more stable. That's why this compound easily lose the Cl minus and getting positive charge. That positive charge is immediately attacked by nucleophile. That's why which is more reactive for SN1 mechanism, benzyl chloride, than the which one? Allyl chloride. Okay, I'm asking one more last and very important bit is nothing but fourth one. So nothing but rate of SN1 mechanism is directly proportional to number of phenyl groups. Number of phenyl groups is a very important bit amount. Number of phenyl. Phenyl means is nothing but substrate. Is nothing but phenyl groups. It's nothing but benzene groups. Benzene groups. Yes, you know very well the benzene groups. Why? Because of involving of benzene, what happening? So many resonance structures is coming. So many resonance structures means so much stability will be there. The compound will be highly reactive. Okay, now I will give you one question. Already you have SN1 mechanism reactivity order, which is more tertiary is more than secondary than primary. That's why I'm writing here C, H, and Cl. It's a methyl chloride. Than methyl chloride we have CH3, C, H, and Cl. What is this one? Primary alkyl halide. After that CH3, C, CH3, H, and Cl. What is this one? Secondary alkyl halide. Okay, write down tertiary. CH3, C, CH3, CH3, Cl. Already we studied in SN1 mechanism reactivity order. What is the order? Than methyl chloride. Primary is more reactive than secondary than tertiary. Okay, but now I am doing some substitution. That means some replacement I am doing. Using carefully. In that tertiary, 2 methyl groups is as it is, but 1 methyl group is replaced with benzene. Then that compound is more reactive for SN1 mechanism. Why? Because here after losing we are getting the carbocation with which which one? Benzene. By involving of benzene, more resonance structures is coming, thus becoming more stable. That's why compared with opposite compound, this compound has much interest to lose CN ions. Whenever it was immediately attacked with the nucleophile, then rate of reaction will be high speed. Than this, I am writing one more. You take instead of one more methyl group, introduce which one? Phenyl group or benzene you have to introduce. Yes, compare with here two methyl groups, more reactive. Than this, all methyl groups is replaced with benzene. See, and after that we are getting like this, and here also we are getting like this, and here see. However, we will ask that this is the important information. Till first time we know very full clarity. So then methyl primary is more reactive than secondary than tertiary. So after that, as the number of phenyl groups or benzene is increasing in the alkyl halide, reactivity will be also going on increasing. Why? After losing you are getting carbocation. That carbocation is involved in the resonance structure with benzene. This benzene, like that more resonance structures is coming, means after losing chlorine the particle is becoming more stable. That's why the compound immediately want to decompose, immediately attack it with the nucleophile. That's why highest rate of reaction. All of you got my point? Yes. Yes. Okay. Again here one more important information. Elimination reaction. Elimination reactions. For competitive point of view is a very important thing, you have to understand very carefully. Elimination is what? Removing something. So just I will give you one example for you. If you take alkyl halide, the whole concept is very important. Please understand very carefully. The alkyl halides will be involving the reaction with either aqueous KOH or aqueous NaOH. We know already what happening. Alcohols we are getting. Yes or no? We are getting alcohols. There mainly what happening? Halogen particle is replaced with OH. Means there especially which reactions will be going on? Substitutional reaction will be going on. That's why it's calling as nucleophilic substitution. No, same alkyl halide will be reacted with the alcoholic KOH or NaOH. Then we are getting alkenes. Why means here elimination is taking place. Elimination is going on. So the whole reaction is not changed. Here we are using alkyl halide with aqueous. Same alkyl halide with alcohol, we are getting different products. So the total information is depending upon alcoholic and aqueous. Observe very carefully. Whenever you are taking alkyl halide reaction with aqueous, we are getting alcohol. There substitution is going on, and whenever alcohol halide will be treated with alcoholic KOH or NaOH, elimination is going on. So we are getting alkenes. Why? Why happening like this? How to discuss? See, first of all, I am explaining the first conversion. Whenever alkyl halides will be treated with which one? Aqueous NaOH, for example. But the basis, let it be. The medium is very important. We are getting which one? Alcohols we are getting. Yes, no? Alcohols we are getting. Because it is going through which reactions? Substitutional reactions. A nucleophilic substitutional reaction will be going on. Okay, why? Why in presence of aqueous base substitution reaction will be going on? I want to explain. Okay, if you take aqueous NaOH, this aqueous NaOH is acting as a strong nucleophile. It is acting as a strong nucleophile. Why? Because anybody can explain. Take NaOH. You know, NaOH is a combination of the two particles. One is Na, another one is OH. Na is a which character? Metallic character. It's becoming a positive charge. OH is becoming a minus charge. Anyway, polar. So NaOH is a polar. He is dissolving in which one? Aqueous. Aqueous means water. Water. Yes or no? Yes. It is also becoming polar. Okay, you know already in the solution which chemical dissolved in which one? Polar dissolved in polar. Immediately it will be breakdown like Na plus OH minus. This OH minus will be acting as a nucleophile. Then remaining process you know very well. What are you getting up? Yes, you take for example one alkyl halide example CH3. C will be reacted with which one? Aqueous LaOH. From aqueous LaOH what we are getting? Strong nucleophile OH minus is coming. Then what happening? The nucleophile will be attacking on halogen attached to carbon. Immediately halogen particle will be coming outside. After that what we are getting? COH, and after that H and H and H, and which is coming outside? Cl minus. So anyway, finally what happening? Alkyl halide will be converting into alcohol with the aqueous NaOH, because aqueous NaOH is acting as a strong nucleophile. So the whole process is going through a nucleophilic substitutional reaction. And no sir, why in second case is giving different product? That is important. Same alkyl halide will be reacted with the alcoholic NaOH. Getting product is totally changing. We are getting alkenes, we are getting here the mechanism is going through which one? Elimination reactions. Why sir like this? The whole thing is depending upon alcoholic NaOH only. Once you take that alcoholic NaOH is not acting as a nucleophile, it is acting as a strong base. Why? Because why don't dissociate? You take NaOH is having which nature? Polar in nature. Alcohol is what? Organic compound. Organic compound is generally non-polar, even though it is a very less polar in nature. That's why what happens, it is almost like a non-polar. This is polar. Is it involved in the dissociation? No. Then what happening? NaOH can be acting as a strong base. Strong base means what is the special character? It's always having the ability to absorb H plus ions. It is ready to absorb which particle? H plus particle from the given substance. That is the character of the base. So then, you take alkyl halide CH3, CH2Cl will be reacted with which one? Alcoholic KOH. I am writing product is CH2 double bond CH2. What happening here? What happening here? Elimination. Which is eliminating? From here H2, from here Cl. HCl elimination. HCl adding hydrohalogenation. HCl elimination. Dehydrohalogenation. Anyway, eliminating. That's why it is undergoes which reaction? Elimination reaction. How it is this one I am explaining to see carefully. For example, from this compound, for my convenience I am writing like CH2H and CH2Cl, which is approaching here at alcoholic KOH. What alcoholic KOH will do? Absorb H plus particle because it is a strong basic nature. So that too here H plus particle, that's why this bond is shifting like this, immediately this bond is shifting like this. Okay, while shifting like this we are getting here plus charge, we are getting here minus. While shifting like this we are getting here plus, here we are getting minus. So H plus is absorbed by this one, that will be coming outside, and after that which is coming outside? Cl minus. So after that this adjacent orbitals is getting opposite charges. I told already. What is it one? Oppositely charged particles will be lying on adjacent particle, they are involving in the new bond. That is nothing but CH2 double bond CH2. So anyway here which is eliminating? H plus and Cl minus is becoming like HCl. What happening? HCl is undergoing elimination, that's why you are calling as dehydrohalogenation. Are you clear? Yes. So very carefully you have to understand, under the presence of aqueous base we are getting substitution, alcoholic product we are getting, same base with alcohol we are getting alkenes. Why? Because here it is acting as a nucleophile, here it is acting as a base. I will give you some example, you can get it. See here for example, I am taking CH2Cl repeating. So what happening here? I am using two different chemicals. I am using aqueous KOH I am using, and another one is alcoholic KOH. Both the cases product is same. Both the cases product is same? No. Why? Under aqueous we are getting which one? Substitution. The Cl with which particle? OH. Then we are getting the cyclohexyl, sorry, there is no conjugation, and OH. You are doing the same thing. Alcohol. Alcohol means what? Elimination is happening. Elimination from where? From here Cl, from here already what will be there? H will be. Why? Because only have 3 bonds. One more bond with the hydrogen. From there Cl, from here H. What we are getting then? 6-membered ring and double bond and CH. Are you clear? Just I will give you one more example. You can get it. For example, CH3, CH2, CH2, Cl. We reacted with aqueous KOH and alcoholic KOH. Very important. These are the competitive bits. Under aqueous, what happening? Substitution is going on. Cl with which one? OH. Then we are getting alcohol. CH3, CH2, CH2, OH. By using alcohol, what happening? Elimination is happening according to concept. From here, Cl, from adjacent H, what happening here? Double bond will come. So that is nothing but CH3, CH double bond, CH. So these are the bits is asking in the competitive examination. Reaction with aqueous, substitution, getting alcohol. Reaction of alkyl halide with alcoholic base undergoing elimination, we are getting